Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox. I've titled this exercise Inlet Efficiency. What we're going to be doing is answering the question right here. How does cross slope and flow rate affect the inlet efficiency using the curb and gutter calculator? All right, so right here in my hydraulic toolbox, I already have a couple curb and gutter analysis started. I'm going to right click, add a new curb and gutter analysis. So let's just go ahead and call this number 3, and then go ahead and right click curb and gutter data. All right. So in this exercise, I have not provided any of the specific details relating to exactly what are the gutter parameters, what are the inlet parameters. I'm asking more of a general question. So I'm looking for trends. Down here in the bottom, we're going to have our results. It's going to show us the efficiency of the inlet, how much of the water approaching the inlet is actually intercepted, and then how much passes by. And then the two variables that we're going to be changing is the design flow right here, and then also the cross slope of the pavement right here. So whatever numbers you use, the trends that we observe here using the calculator and some example numbers should be the same. All right, so you're welcome to follow along with me and use my exact same numbers or use some of your own numbers, but either way, let's go ahead and get started. So for the longitudinal slope of the road, I'm going to say this is 0.01. By the way, this does have to be a non-zero number, so 0.01 is what I'll go with, 1%. Now I'm going to be keeping this constant, even though this is another variable I could be changing. All right, so the cross slope of the pavement, this is one of the two variables that we're going to be changing. And just to kind of give you a roadmap of where I plan to go with this exercise, I have an Excel file here, and it's going to allow me to keep track of the inlet efficiency for a range of 3 different flow rates from 0.2 CFS up to 1 CFS, and for cross slopes ranging from 0.5% up to 4%. So what I propose we do for this very first calculation is make this calculation right here for the 0.2 CFS, 0.5% cross slope of the roadway, and then continue on with all the other calculations. All right. So I need to go ahead and just commit to this 0.5% cross slope, which is what I'm going to be putting in here. So 0.005. All right, next up, I'm going to define a cross slope for the gutter. I'm just going to say it is flat, so 0. Manning's roughness, I'll go with 0.015. That looks good. The gutter width, I will say is 2 feet. So, okay, that's already there. Default value. And by the way, if you don't have English units or US customary units, you can go ahead and set that. I'm going to click OK real quick. Please enter a non-zero value for the flow. Okay, well, anyway, you can change your units by going up to units and then US customary units. You can also make that change right here in this dropdown. Okay, back to our data. That's good. It looks like everything's saved. Now for the design flow, I'm going to start off with the first flow rate of 0.2 CFS, which is right here. So 0.2 CFS, and click on compute unknown. That's going to give us some of our hydraulic parameters right here. Not ready for efficiency yet because we need to specify some inlet parameters, and then we'll click on this compute button and get our final results. All right, so for the inlet location, I'm going to go with inlet on grade, which makes sense because we have a longitudinal slope to the road. After that, we have to specify the inlet type. Our options are right here. I'm going to go with the equal length combo. And then for grate type, we'll just go with this first option here, P1 and 7/8 inches. And then the grate width, again, this is sort of up to you, but I'm just going to make up some numbers. So 18 inches is what I have in my notes, which is 1.5 feet. And then the length, I have 36 inches, which is 3 feet. All right, so I'm going to tab off. Local depression, I'll say is 0. And it looks like my button for compute inlet data has now been enabled. I'll go ahead and click that. And then here are the results down here. What I'm seeing in the results is that the intercepted flow is 0.107 CFS, which means the bypass flow is 0.093 CFS. So these two summed up together equal the total flow of 0.2 CFS, which is not a particularly good efficiency. we barely captured more than 50%. In fact, that number is right down here at the bottom, the efficiency. This is the number that I'm going to be copying into my Excel file. So 53.3%, but I'm going to record it as a decimal, so 0.533. Okay, so I'll put this off to the side. I'll go 0.533. And then after that, I'm going to just move over to the next flow rate, which is 0.5 CFS. And with everything in my calculator already set up, I don't need to go through everything again. I can just very easily change 0.2 CFS to 0.5 CFS and then recompute. And now out of 0.5 CFS, it looks like 0.210 CFS is intercepted and then 0.290 bypasses. So the efficiency in that case is only 0.421. That's actually worse than it was at the lower flow rate. But regardless, those are the numbers. That's what the calculator gave us. I'm going to type those numbers in here, 0.421, and then advance to our largest flow rate of 1 CFS, sticking with our side slope of 0.5%, that cross slope of pavement. So let's go with 1 CFS and then compute. Now out of 1 CFS, it looks like only 0.344 CFS is intercepted, and then the remaining is bypassed for a efficiency of 34.4%. So back to the results, 0.344. Okay, I'm not going to record me doing this another 12 times, but I will do this last one here because this is where we changed the cross slope. Previously, we've been using this 0.5% cross slope up here. And what I'm going to do now is just change this to 0.01. And according to my notes here, the first flow is 0.2 CFS. So let's reset the design flow to 0.2 CFS, compute, and compute. So now out of 0.2 CFS, we've intercepted 0.132, and the bypass is 0.068 in units of CFS. So that efficiency has increased to 65.9. I'm going to type in 0.659 though, and there we go. And already we can kind of get an idea of what the trends are going to be with this same flow rate, increasing that cross slope of pavement from 0.5% to 1%. The inlet efficiency is increased 53.3 to 65.9%. All right, I finished that up. I finished populating the table of data right here. So we can look at the numbers, but it's a little easier to show a graph. Here is the plot, the XY scatter graph. What I'm doing in this plot here is the inlet efficiency is plotted on the vertical axis that is dependent on the cross slope of the pavement, which is plotted along the horizontal axis here. As you can see, for all three flow rates, the efficiency increases as the cross slope of that pavement increases. Again, that cross slope pavement is ranging from 0.5% up to 4%. Another conclusion or trend that we can develop from looking at this plot is that at the lower flow rates, we're going to have a higher inlet efficiency. That's for the same slope. So right here at 2%, we have the highest efficiency at the 0.2 CFS, and then the worst efficiency at the highest flow rate of 1 CFS. Over to the right, I added a second plot now. This is also with inlet efficiency as the dependent variable on the vertical axis, but now it's plotted against flow rate. So instead of each series being a flow rate, now each series is a pavement cross slope. And from this plot, we can basically derive the exact same conclusions that we did previously. That is, as the flow rate increases, the efficiency decreases. And then looking at our series data here, as our cross slope increases, so does the inlet efficiency. All right, well, that's it for this exercise. What we talked about was the inlet capture efficiency and how that was related to the flow rate as well as the cross slope pavement. And that was using the curb and gutter calculator within the FHWA hydraulic toolbox.